good morning, and a very warm welcome to HDR's Talk of the Town. As always, so lovely to see familiar smiling faces and close industry acquaintances in our audience. Absolutely super to have you here in our London office. My name is Farah, and I'm the Marketing and Communications Director for the Global Building Engineering Services Business Group here at HDR. Before we delve into our talk, Navigating Technology in the Real World, I would like to share a potted history about our brilliant speaker. Born in New Jersey on the east coast of America, David spent most of his idyllic childhood in or around the water, either boating, sailing, fishing, surfing, or even acting as a lifeguard. During high school, David developed an interest in computers when he started to create web pages for non-profit charter schools and then for the family business. David's journey into the complex world of control systems and cybersecurity began while studying at the University of South Carolina, where he earned a Bachelor of Science in Computer Engineering. As a student, he participated in a cooperative education program that introduced him to control systems as a profession. It was during this experience, seeing his designs interface with real-world equipment, that he discovered his passion for engineering. From that moment, he was truly hooked. It was also at the university where David met his wife, Jennifer, who coincidentally was also from New Jersey. Despite growing up just 45 minutes apart, they did not meet until college, thanks to a mutual friend who introduced them when Jennifer needed a ride home for the holidays. As David liked to say, you learn a lot about someone during a 12-hour road trip each way. Upon graduation, for the first 15 years of his career, David worked as a systems integrator, implementing control system solutions across all 16 US critical infrastructure sectors. This hands-on experience gave him a deep understanding of how these systems operate in the real world. After joining HDR as a control systems project manager and networking expert, David continued to expand his technical and leadership capabilities. In 2017, he was invited to attend a cybersecurity training session focused on new requirements for the US Department of Defense. That session became a pivotal moment in his career. Leveraging his background in controls, David began translating cybersecurity requirements into practical, actionable guidance for design teams and contractors. His ability to bridge the gap between engineering and cybersecurity led him to being tasked with leading and developing HDR's cybersecurity teams. Today, David serves as HDR's Global Director of Control Systems, Operational Technology and Cybersecurity Services, where he leads a multinational program that spans consulting, assessment, design, compliance and reviews. His work supports critical infrastructure, government, transportation, water, energy and in the industrial sector, helping organizations navigate the evolving landscape of operational technology and cyber risk. David combines his technical expertise, leadership, experience, and personal values to fulfill his mission, which is driving smart control solutions for a safer digital future. And just before I introduce David, I just want to check with everyone, we are filming. If you do not wish to be in the final edit, speak now or forever hold your peace. Are we all good? All right. And so without further ado, I am truly delighted to introduce the incredibly charming and brilliant David Brearley. Thank you.
Good morning. Thank you, Farah, for the lovely introduction. We'll go ahead and get started. We really wanted to start on background history of control systems. So control systems, when we look back, really started with, we call it Industry 1.0. Industry 1.0 is mechanization. It's the first time we started to bring the engine into our factories. It is the very early stages of automation. As we progress, we go to Industry 2.0, electrification. Electrification is not what we think about it today. Today we're talking about electrification as we're electrifying our buildings, our boilers, our cars, everything in it. Electrification was those first electric motors coming into our factories when the Thomas Edison days of cars, when we started doing our automation. We progressed into 3.0, our automation, our very early stages of control systems, the very beginning of control systems. And now we're transitioning. We head into Industry 4.0. 4.0 is kind of around the advent of the internet, the industrial or the IP-based protocol, the Ethernet equipment that we plug in, our laptops, our equipment. And now we're into 4.0 or 5.0, which is all about personalization. We log in, we have a personal dashboard. We have our VR headsets. It's really advanced where we're going. It's really unique in the fact that we're seeing this digitization of everything in our lives, including the industrial world. My question is, what does Industry 6.0 look like? We don't know. We don't have a date. We know we hear every single morning in the news about AI. What is AI going to do to how we use systems in the world, how we produce, how they live in our everyday lives? I don't know, but it is that trend. I couldn't tell you what it's going to look like, but we know it's coming. So I think about cybersecurity, just a quick background on cybersecurity. A lot of people think about cybersecurity as a relatively new idea or a relatively new career path, but we can really date it back going all the way to the 1800s, France. Believe it or not, we had no computers in the 1800s. So the first hack, when we think about the first hack, was somebody who actually attacked a telegraph system to gain market data for a competitive position. That's a really long time ago. We advance a little bit further. Pre-internet days. So for anybody familiar with the term, they called it ARPANET. The original internet was called ARPANET. It was designed for universities to share and collaborate in research. It was a great intent. We do this, we think we can improve how we do our research. Nobody thought about a potential malicious use. So what you see here is the first message that got sent out for malicious use. It spanned the world very, very rapidly with unknown consequence. It was a big uh-oh. We didn't think about security. We thought about the fact that this would be an awesome collaborative environment. And now we move forward. We get to the 1980s. I'm a child of the 1980s. I love our bad 1980s movies, our books, and this is really where we started to see the term cybersecurity coined. It's the first time we really used this as a term. You saw it in movies, you saw it in this book here, and it was the beginning, but it was very focused in on that IT realm. So cybersecurity really starts when we around physical security, our background in just general security. We can't have cybersecurity without the basis, the beginning, security as a whole. So when I think about security, I like to start with just a very basic framework. You know, our homes. Our homes were designed for protection from the elements. It is a physical security, weather, temperature, those events. As our homes progressed, we added windows, we added doors, additional layers of security. Why? Because maybe our risk profile changed, our expectations for risk have changed. At some point in time, we decided that locks were important. When we leave our homes, we did no longer trust that somebody that was going to knock on the door and not come in when we did not answer. What are we doing? We're lowering our risk tolerance. So today, that's not what our homes look like. So when was the door lock not good enough? When was it that we left our home and got to the point where we can see now who's at our front door? We have security systems to respond because we don't trust that lock set. We want to know when somebody is not there. I love these photos because the burglar is inside and the cat is on the doorstep. This is probably not the way we want to see it when we log in on our phones. But what this is doing is really setting the stage for, it's all about risk tolerance. So the measures we're putting in place, we adjust to what our acceptable levels of risk are, and that has changed over the years. So technology is changing, and we're going to see how technology has changed. We're going to see that same progression. So New York City, very early 1900s. We just talked about the electrification days. So here's New York City, early 1900s. What you're going to see is mostly horse and buggy. 2 automobiles on this particular picture. We're going to advance. We're going to go forward just 13 years. So now what we have is just 2-horse and buggies left in 13 years. The rest is automobiles. Think about the infrastructure it took us to get there. Automobile manufacturing, fuel generation, fuel stations, service stations, air pumps for the tires. All of this technology that we built in just 13 years. That's a pretty fast ramp, but now let's look at what it took us to do this with other technologies. So this is the acceptance rate of technology to get to 50 million users. So if you look at airplanes, roughly 68 years. You're working your way through and you're going to see this exponential ramp, faster and faster. We get to the telephone, the window has gotten even shorter. We get into my favorite. Everybody remember when Pokemon Go was the craze? It was all over the news. I guarantee it was on the nighttime news. It was the app that everybody's running around town and walking out in front of taxi cabs because they were chasing the Pokemon. 19 days. Zoom, around the time of the pandemic, transitioned to over 50 million users in under 12 hours when we all shut our borders. That is a very rapid change for us to have to address the security of those platforms, the buildup of the technology to keep those and maintain those and operate those. We're now seeing the same thing in the AI space. ChatGPT, moving very rapidly. It is something we're going to continue to chase. It is coming, and we're not going to stop this digital revolution. So it's part of our everyday. I'll leave the quote there for everybody to think about, but we all know it. We can't navigate without a phone in our hands. We get our cabs via the phone. We call our Ubers. It's part of our tube system here. It's the aircraft. It's just become part of our everyday, and it's not necessarily even an option anymore. We used to buy technology as an option. It's really what we need in order to serve societal need. We need more efficient. We need production. We're serving a much larger population. So I pick on my architect friends. I love to pick on my architect friends. There's probably some in the room. And I jokingly say, you're building me a beautiful wrapper for my technology. If you walk into any building, any mall, any facility, any establishment today, you look around, and it's very hard to look to not see technology. We're really building a much more complex environment. So when I think about healthcare, just a few snapshots thinking about those different environments, right? It's our medical devices. Our medical devices are connected to the building now. We need that data. This particular room has intelligent lighting. It has an HVAC system that's being monitored when you're in surgery to make sure we keep the temperatures within what's expected for the environment. It becomes part of your patient record. It's all these systems that we're building and wrapping around. When we come into this building today, I think about my morning. I get up, I came around the corner from the Hilton, walked past the traffic light, walked past the tube station, came to this building, I had to get my badge, walked past my security cameras. It's this room with the HVAC controls. You see them on the wall, the lighting systems. It's really everywhere. And it can continue to be everywhere. The question becomes, where does that get secured? When does it get secured? So in a hotel environment, I get the, I'm going to call it the beauty or the leisure of spending almost 100 nights a year in a hotel. I travel quite frequently. And what I'll say is that we're getting really good about this big data use. So I got to spend a night in a brand new hotel just a few weeks ago where I walked into the hotel room and they have enough data on me through their BMS, through their property management systems where they know the temperature of the room that I like because it was already set. My name is on the TV. The drink that I like arrived at my door 10 minutes after I checked in via a robot. The robot rode the elevator by itself, knocked on my door, knew my name, and knew I was in my room, because otherwise it would not have delivered. It would have come back later. This is really where that technology is going. It's a very large data set. So around the world, we're all faced with drive to net zero. And the drive to net zero, what I'm seeing in the built space is that this is causing us to consider new technologies to help us with those efficiency gains, the recapture, the renewables. If you take a building like this, what happens to a traditional building? We used to have HVAC, electrical, a security system, right? Your basics. Now we start to add in automatic window shading, rainwater capture, solar pane glass. Every one of these systems, and the more systems we add, the larger the potential footprint is. We call this the threat footprint. It gives me more potential ways to attack those systems or ultimately the building when it's said and done. So cybersecurity on the control system side is a relatively new field. We built all these things to be available, to be a convenience, to make us more efficient. Roughly 10 years ago, just over 10 years ago, was the first time we saw a virus that targeted industrial control systems. It was called Stuxnet. It was our wake-up call, where we used to look at these and say, yes, available, the lights are on, the water runs, we're happy. So anybody who's in this field that's looking at this built environment and the control systems that run it, we all started around the time of Stuxnet. It was really our first moment of we need to start thinking and designing for security. As we progress, though, we really haven't changed very much. So I put this up here just so that folks know there's great reports out. This is one of the annual reports that comes out that talks about what is the risk posture in this environment? What are we seeing? What are the types of breaches? What are the owners doing to help control that footprint? Unfortunately, we haven't changed very much. So I'm going to pick on France just for a minute. There's a couple of websites out that allow us to see industrial control systems that have exposure to the internet. This is a site called Shodan. So when we were doing preparation, I ran a report for Europe. We're just going to go through a couple of examples. So a site or a system that is exposed to the internet means I can see it. I need zero skill. I need zero time. I need zero patience. In France, at the time that we had run this report, 3,970 systems that require me to have zero skill, zero effort to impact that system, that building, that facility, whatever that may look like. When we zoom out just a little bit, I don't want to pick just on France. So here's Germany, France. I'm from the United States. I'm sorry, my number is the highest. There's a lot of us working to improve this posture. Unfortunately, if you think back to technology proliferation, what we're just showing in terms of the usages, there's more systems introduced into our built environment every year. So the numbers you would expect as we're learning about cyber would go down, but because we're introducing more systems, because we may not be putting the requirements into how they're being built and secured, the numbers continue to increase. And these are what I would consider to be those low skill. These are the ones that at least I can see. I didn't have to breach a firewall. I didn't have to send somebody into the site to get to. So just from a different report, this one's from Hacker News. This gives us the global view. So as of 2024, 145,000 systems that live in that same state, 23% here in Europe. So kind of a scary world that we're living in when we think about these systems. In Great Britain, I really just wanted to get everybody an idea of the types of systems that we can see. So what you're seeing here in Great Britain in that same snapshot, a lot of your CCTV cameras, which a breach results in a breach of GDPR, not a great stage. The digital video recorders that are associated with them, which means I can actually go in and play back and watch the video of you walking into your home if it happens to be on there. MQTT, if you're not familiar with MQTT, it is for the Internet of Things type devices. So if you're in an office environment and you walk up to a conference room and it has one of those little scheduling boards, typically that's an IoT type device. Our thermostats, if you have a thermostat that you can access from your phone for your home, that is an IoT type device. So we're seeing those out there. What surprises me is that number is low, which means at least when we're home, people are changing some of their default settings or the suppliers we're using are helping us. And then this slide I just wanted to spend a minute on. So here in Great Britain, we do a snapshot, and the snapshot allows us to see the actual vulnerabilities and how many of those devices that we just exposed have known vulnerabilities, meaning the US government in conjunction with Cyber Center here in the UK and the Five Eyes partners publish known vulnerabilities freely on the internet. You don't need a login, you don't need a background check. They're available to me as a good guy. They're available to our adversary as well. And the reason we do that is if we don't know about it as a defender, we can't fix it. We can't change it, we don't know, and we continue to add the risk. So these CVEs on the left-hand side, when you look at them, they're built based off of CVE, the year they are defined, and an index number. What you're going to see up here is there's some of these devices that have a known vulnerability, meaning I already know how to attack them, that have been on the internet since 2015. Nobody's done anything to them. Pretty scary. We got to think about how we maintain our systems. The CVEs are great because it does allow us to move forward with that. We have a plan. They don't publish CVEs until the vendor has given you a solution to whatever the defined definition is, whatever that problem was. So the UK has had quite a few challenges this year. You've been in the news with 3 major incidents with M&S. Jaguar still fighting some of their challenges to get back online. And in the US, I really like to talk about the built environment. So I'm going to focus in on MGM Grand just for a few minutes. For anybody not familiar with the MGM Grand attack from about 2 years ago. So MGM Grand, one of the largest hotels on the Las Vegas Strip, had a breach. That breach occurred via a phone call. Somebody called in, pretended to be an employee, spoke with confidence, conviction, and essentially convinced the person on the receiving end of the phone to unlock the door, open the door to allow them into the system. They were down for roughly 7 days at a net cost of $100 million. That breach, because we rely on our card keys for everything in a hotel, stopped you from going into your room. The elevators would not function, and they could not gamble on the gambling floor. Their losses were substantial, primarily around the gambling floor and having to move people out of their hotel rooms because it was unsafe without the elevators to have a fully occupied hotel. So last week, as we were finalizing preparation, we got new news. New news came out from National Cyber Center here in the UK as a joint advisory with the Americans that says we need to do something about these control systems. Here is our recommendations, and it hit a baseline of 4 or 5 recommendations for all owners because of the frequency of attacks that we were seeing on those systems. You can get to those through National Cyber Center. It gives us our baseline starting point. We'll talk about some of those here in a little bit as well. So now that I've successfully scared everybody for a little while, cybersecurity is really just risk management. We all accept risks every day. We jump in cars, we fly on airplanes, we go on the tube, we live in buildings. We can't escape risk. So cyber is just really a modern risk, right? We're relying on digital systems. So I'm going to let everybody read this great quote just for a second, because I think it's really a good spot for us to start when we think about our relationships with technology. So when I think about risk, I get to partner with our different disciplines throughout the business. And one thing that we realize is that the university system is not caught up to identifying this as a traditional risk for those mechanical, electrical, civil, plumbing disciplines. We're teaching them how to use the technology. They're the designers of the technology. But if you look at the chartered registration exams, if you look at the professional engineering exams in the US, they don't account for this as a known or foreseeable risk today. So we really need to start to help them and supplement to understand and control this risk as we move forward. So because of the designers, they know their systems the best. They know what those are. They work with those vendors quite frequently. But when does cyber get applied? How does cyber get applied is really becomes a question. When does this become that foreseeable risk? How do we support those disciplines, supplement those disciplines to give you a system that is operable, meets your efficiency goals, is maintainable, because you don't want me to secure it to the point where your staff, your facility management team can't do anything with it. And I could build you something so secure, but it'll never run. Right? A brick is great. It's not hackable. It's not controllable. A push button is awesome. Why? Because I can't hack a push button. It's all about kind of understanding that and supplementing where we're using technology, building that understanding into the process. So this starts with goal setting. We really set goals for every project we do at the very beginning. We define our area. We define the loads that we want on floors. Our code defines things like fire ratings. We set expectations for the project. For cybersecurity, because we don't have a standard of care set today, it really starts with thinking through our consequence. So what is our potential consequence of loss as an owner, as an engineer, as a user, and what's acceptable levels of loss? So Jaguar's got a challenge right now, right? They're in the news. We have some reputational challenges. Their impact is financial to their supply chain. When we come across the line, investor confidence. Are you providing some sort of investment grade system, or do you have to meet an investor goal for operations? Our market position, we certainly, it kind of goes with reputation. Operational efficiency when we're in a factory or here in the building, just to relate it to a very simple building. The lift is a convenience item as long as you have mobility. But losing our lift would be terrible for walking up 7 flights of stairs to come here and have a nice hot cup of coffee or a hot cup of tea this morning. Our HVAC system, as the room gets a little bit warmer, is an inconvenience for us as a human. In a data center, that is detrimental. We will lose those servers. They will turn off. Then we go back to reputational damage. We go back to that efficiency because they've signed for goals that says we're going to stay online. So it starts with understanding those because that allows us to scale. We scale our investments in cybersecurity to meet that tolerance or to meet that end goal, that risk. The next thing to consider, and these are 3 questions that we've seen now coming from our insurance providers. So Lloyd's of London was one of the first ones to come out that says, cyber is very difficult to understand. It's very difficult for us to do the underwriting and understand the risk profile because insurance companies don't like to spend money. They do not like to pay claims. They don't make as much profit. So the underwriting now is specifically addressing the operational technology, the control systems that support your operation into policies such as business continuity. So these 3 questions came out of our underwriting questionnaire. I see them in many. What does it ask for? On the left-hand side, it says, did you apply a best practices framework? This one references ISA, International Society of Automation. Do you have a disaster recovery plan that states what you're going to do and how fast you're going to get back online? What does that do? It controls their exposure because it says we have a plan that we have tested that says we can be online 8 hours later. Or Jaguar, we're looking at weeks, right? So it gives them a known exposure window. Our worst case is that you can't use that facility for a day. And then the last one is looking at, do you have the documentation necessary for a team to come in and support? It's an asset inventory and network diagram. The reason it's really important is if we don't know it's on a network as a responder, we don't know if it belongs there or not. We're going to turn it off. If we try and rebuild something from scratch and we're in the built environment like this, we're going to be popping ceiling tiles to find every device that happens to be plugged into a network versus having the drawings that show us. It's changing how long it takes us to respond. We also know that any of those outbound communications either belong there or they do not. So we start by writing this very early. We put this in the project plan, the expectations, the RFP, the RFQ that is going out to your consultants. Set it as a goal. If it's not written down as a goal, it's very unlikely it's going to get applied by anybody in the life cycle of your build, of your project, because it's new and we don't have that stated standard of care. It's not like doing code or regulation. So we start very, very early, set that end goal. So you heard me talk about it. Cybersecurity is really a team sport. You heard me talk about the other disciplines, but when I say team sport, myself as a consultant, I can't set your risk tolerance. I can't tell you what's acceptable. I can be a consultant to help you understand what is possible. What can I do to those systems? What is the potential impact? So it starts with a partnership. It's consultant-owner. Owner, consultant, constructor. Because we need to make sure whatever we've put into plans ends up being built. We go another stage. Who's operating, maintaining? Facilities management. Because we don't want to give them that system that they can't operate, they can't maintain, so they become part of that. Our whole team has to add together at the same time. If we don't get acceptance, you're going to find something like facility maintenance finding a shortcut around all the best practices we just put in, and once you put that shortcut in, we go back to MGM Grand. The door is open because we didn't follow what we set. Once we're under design, this is where we partner and we supplement with those other disciplines. We help them with the understanding of that risk profile, what's capable of those systems, and we start helping tweak a little bit how that lays in design. You heard me say a minute ago, push buttons are awesome. I'm going to be the first cyber person you ever said, don't use laptop. Push buttons awesome. It's a great risk mitigation of backup. Because if I need to run a pump, I can walk over and push a button. I can't hack a button. I can at least get that system online. It might not be efficient. It might not meet the end goal, but if that is part of a life safety system, it's great. If I put a little digital display to replace the push button, I may have lost that digital display in the hack along with the push button. So this is a partnership. We don't think that the MEP traditional university is going to catch up for several more years. So this is really a partnership, and we don't want them to be experts in everything, right? We want them to be experts in a discipline that they were trained in, do that really well, and we will help them. So this starts, when we think about the design process, this starts with our physical space requirements, our physical security of equipment. You do not want me to have time to touch the equipment, because with time, we'll find a way. Hackers are great. They're going to find a way. They'll get all the way down into your chip, into your board. They'll find a way to breach that device. So it really starts with physical security. Broader, though, when we think about space definitions, do we want our IT or ICT type networks to be merged with our OT networks that support life safety and others? It's a decision. It may affect the rack space. It may affect the room space. With certain owners, especially here in the US, where sometimes they ask us for a completely separate IT closet for their building automation and for the medical systems because they feel that it's more sensitive. They don't want the same people to enter and have access. We're affecting the floor plan very early into design. So we start with that. We really set those expectations. And now we dive down a level and we start to look at our typical stage one here, but our ICT considerations. So we think about the networks. Are there vendors that we do not necessarily want to be procuring from? There are specific guidances out there from UK as well as US on potentially some vendors that we shouldn't use that have some, I'll call them supply chain challenges. When we think about the isolation, do we need two switches, one IT, one OT? Typically, the way we work with our ICT teams is when we come in for cyber is we'll define the overall architecture. How do we secure this network from a block diagram architecture? And then we work with the ICT team to define the requirements of that type of equipment. We let them do all the physical routing like they always have, but it's that partnership to really take us through the process. And then we get into performance-based requirements, specifications, RFP documents. And what we're talking about here is very heavy on the documentation and configuration side. We don't want to just plug things in, set it and forget it. We don't want to take defaults. This is really supplemental to the way we used to define equipment. We used to leave it all up to the OEM. Now we're setting the requirements for the OEM. Change my default username and password. Don't let me go find it on the internet because it's in your O&M manual. Think about things like our software and firmware updates. So if you remember the CVE scores we talked about a little while ago, they're all fixed via a software patch or a hardware patch. When your contractor buys a piece of equipment, it goes to typically a warehouse of some sort. That equipment was manufactured 6 to 12 months ago. We've discovered vulnerabilities during that time frame. Why are we accepting a brand new piece of equipment in our building that has a known vulnerability versus building it into our performance spec that it gets updated at the time of turnover? So at least the thing that we accept that day is known at that time. And then we can get all the way down into the ones and zeros. The encryption and all the things that I'm not going to get into today because we really don't need that deep technical, but we need those carved into the spec if we want those to lower our risk profile. It's really about what we're trying to drive from our contractor, and then how do we witness it? Cyber's fun. We can't see it. We're really good at building commissioning. We can pressure test, we can monitor systems, we can look at the temperatures, we know if our window is leaking. Cyber we can't see. What's the expectations? How are we going to test that? Is it on the contractor? Is it on an owner team? Is it a third party team? In the US, they're starting to talk about cyber commissioning as a service because we need to get into the equipment, look and make sure that what we ask for in configuration is actually what the contractor applied. I jokingly say I don't like the contractor looking at it because it's kind of the fox over the hen house, so to speak. I'm the one who put it in. I said it's good. I promise you it's good. And nobody ever checks it. It's a good starting point, but certainly to make sure we get what we ask for is contractual best practice. There's a few things that we do like to address that happen outside of the construction environment typically. And I'm just going to touch on 3 of those that are really owner best practices. Starting with policies and procedures, we talk about governance. Governance is really a chance for us to set the expectations for all the stakeholders who touch our system, full life cycle. What do you expect of us as a consultancy when we come in to support you? What do we expect of the contractor? What do you expect of our facility maintenance team when they make a change or we bring a vendor in for support? Is that vendor allowed to bring in their laptop? Or are they using something that you already have in the facility? They've made a change. We talked about the fact that we need updated drawings and asset inventory. Are they updating it or are you updating it? If you're doing a multi-project or you want to be consistent across a portfolio, you can use standards to make sure that as you go from consultancy to consultancy, contractor to contractor, you're controlling and getting that same profile of cybersecurity throughout. It gives you a much easier platform to monitor your risk. The next one in here is monitoring and maintenance. We talked about patching, we talked about CVEs. These systems, unfortunately, need to be maintained. We need to treat our digital infrastructure as we do our other assets. We're really good about asset management, but typically your digital infrastructure in an asset management system at times will show up as a single line item. Hey, here's our BMS. When we dive into the BMS, it's got multiple layers. It's got computers, it's got the BAS panels, it's got the end devices. They really need to become part of a maintenance program to mitigate those vulnerabilities. We need to have the budget or the staff or a contractor assigned to have those done. Monitoring you will see in every single cyber standard is a best practice. Watch those systems, have something on our network watching those systems. Tell people all the time, monitoring system is awesome, but only if you have the staff assigned or a contractor assigned to watching it. Otherwise, we've bought ourselves a forensics tool at best. Doesn't do us a lot of good. So not everybody will have a monitoring system, but if you have a more complex portfolio, it will help you identify that risk much earlier of something happening, shorten your duration of that response. And then the last one is really, this is continuous life cycle. If you look at any risk management framework, what happens? You get to the end, you implement, you start monitoring, and you loop back. Has your risk profile changed? Did the insurance ask you for something new? Did something geopolitical in the world happen where our risk has changed? Maybe one of our pieces of equipment is no longer supported by a vendor, meaning once a vulnerability is discovered, there's really nothing left to do but to do that upgrade. So identifying when and how we're going to revisit is an important part of the cycle, especially if your risk tolerance is on the lower end. So because we're sitting here in London, just to kind of bring this back to that whole REBA approach, recap this section a little bit, as we go through the stages, we all know the stages, but if we think about that stage 0, the stage 1 very early, what did we talk about? We said we need to set the expectations for the project, because if we didn't write it down, I'm sorry, it's just not getting done. We work our way into that 2-3. We start to work in the physical environments, setting equipment. We're really defining out what's our physical space, what's our performance requirements, what are we expecting of the contractor when it's set and done. We build it. Who's doing this work for the contractor? Making sure the contractor actually applies what we built. It's going to be new for some contractors. Some contractors may not have seen this. I'll tell you, most of our building automation type vendors are starting to become much more mature in this space, so they wouldn't be surprised by seeing the requirements come in. We work our way into turnover, making sure we get the backups, And then ultimately doing that turnover to facility maintenance and making sure they maintain and don't go around and put those little bypasses into the system that we know they love to. It's just been ingrained in them over the years. So really to start wrapping us up, what I wanted to leave us on is the fact that cyber is much more efficient when we bake this in early. We make it part of our project, it's included, we get the better ROI. If you just think about what it would take us to go through this building and understand everything that's in this building, maybe change how it's wired, do upgrades, move people out of beds if we're in a hospital to do maintenance. It's a lot easier if we start to include this and just maintain it throughout the process. Set the expectations, hold it, and maintain it. And then really, we start on frameworks. If you get out on the internet, one of the questions I get quite frequently is, how do we know? How do we know what's good enough? Well, technology is going to keep changing. The frameworks that are out there today are really foundational, allow us to build for that future technology. So the mitigations put in place will be good for the future. And I'm going to leave you just with this last quote to kind of read and the question, when? When does this become that foreseeable risk? When does it become part of your expectations for a project? Because until we put it in place, either via regulation or this whole team starts to ask, it's going to continue getting put in, or we're going to keep seeing the numbers go up. So I'll pause there so we can get into some question and answer. I appreciate it.
Hi, I'm Daewak Kang, architect in London. It was really interesting to see, and I guess we all experience IT every day. I was just thinking as you were giving your talk, as a user rather than thinking of myself as a designer, it just feels like every day there's just more and more digital technology that I use, and at a certain point it feels like the number of things that I'm dealing with completely outpaces my interest or ability to actually pay any attention. So at a certain point, just stop worrying about sharing data. So one of my questions for you is how are we managing as an industry? Is it actually possible to keep up with the amount of proliferation that's going on, or does it just become such a huge tax on actually that it just becomes infeasible to keep up economically with actually maintaining all of this security?
I think that's a question that if we all had the answer, we could retire tomorrow, to be honest with you. And really, we're seeing this in the data center space, right? I relate it to AI. We get the question, how much more AI, how fast can we go because of what they're building? The technology that we're building can support the growth. And the reason we can support the growth is we're seeing changes in how the technology itself is designed, right? We're seeing water-based cooling. We're seeing chips get smaller and smaller. The challenge for me as we think about our environment and our world is, how far can we go with technology and still have the staff and the funding to maintain it as we put it in? And I think that is part of that early risk discussion, is if we're using the technology, especially where it's an option to us today, is there a business purpose for it? And is the business purpose adequate to support what it's going to take us to operate, maintain, refresh over time? Because technology just for technology it's fancy, but does it really meet our end goal? And I think we might need to start there and have those conversations during our very early design stage or our very early planning stage. It says, how will this support your mission? How will this support your goal? And if it's not, maybe we need to prep for it for the future, but maybe it doesn't make it to that project.
That was exceptional. Thank you very much for that talk. I'm Nora Chaki. I'm from Adams & Associates, Executive Architects. With all these systems that we need to be aware of and to have in place in our day-to-day life and also in our work and in our projects, we are obviously relying very much on the production of microchips and microprocessors, which is, I think, primarily in Taiwan or something like that. And I wonder whether there is a big risk of what happens if that route gets disrupted. What will we do, and how will we go back to analog? Do we have to do that, or what is the plan B?
Yeah, so when we think about manufacturing, we are seeing a push to diversify our manufacturing supply. I referred to the question of which vendors will we maybe want or not want in our system. So what you'll see from the Five Eyes countries, those of us, Britain, America, Australia, that share data, there's already a set of vendors that they defined out of certain countries, China included, that we know we're not going to use because we're having chipset vulnerabilities. I think our overall supply chain diversification, we are seeing an increase of semiconductor work in Europe as well as in America to give us that diversity. I do think analog might be an option if we ever truly lost that supply, or we'll pause. We saw this during the pandemic. We're living it today. If you think about a building's utility grade transformer, it's currently a 48-month supply chain. A generator, a turbine, is a 48-month supply chain. We're already facing this and coming up with solutions, but I do think it's putting us on the brakes a little bit and maybe giving us some time to build cyber into what we have before we go to that next step.
Hi, my name is Leo from IDS. I had a question. So part of, I think, especially since COVID, we've seen this mass shift to work from home, which seems to infinitely expand sort of the risk exposure with you can control all the devices you have in an office building, but then you have your kids' toys and whatnot at home, all plugged into the Wi-Fi that you use to do your work on your work laptop. What have you seen kind of clever ways of managing that?
For home use, mixed with business use, yes. So I can tell you in my home, I actually have 3 networks set up coming off of my Wi-Fi. So I have a secure network that is set up only for my work purpose. I live 100% on VPN because VPNs are more difficult to hack, but not impossible. I do have a secondary network for my entertainment-based systems that is also bought through a VPN solution to secure that network on the inbound and outbound. I tell everybody when you get your kids' toys, go in and change the default usernames and passwords on all of them. Because 2 or 3 years ago, somebody was talking through nanny cams and pretending to be Santa Claus using the defaults. And then a third network for my miscellaneous stuff that's a little less secure. It's kind of my guest network. What I would say that has been a challenge across the world is whoever your provider of internet services is typically provides a router or a piece of equipment, asking them to patch, update, or if you're allowed to do it yourself. It is a very simple process. Will make you much, much, much more secure. If you want to read about that, read about the Chinese and the island of Guam and what they're doing in Guam, because they're positioning off of the internet providers. So more network security than we're used to, but most of your current commercial equipment will allow you to build that with just drag and drop, move devices into the zone you want it to be in.
Hi, my name is Raja and I work for Turner & Townsend, and actually I was having a conversation with Leo, and he was telling me about a friend of his or somebody who lost a mobile phone in Beijing. They went into a police station. The police said, well, where did you lose it? They had all these cameras and everything. They managed to track that guy down, scan his face, get his name and phone number, call him and ask him, where's the phone? And so, oh, I'm bringing it to the police station. And he comes in half an hour all sweaty. Oh, yeah, I found the phone for you. Can I ask you, I mean, this is sort of like technology that's really good, but also invading privacy. I mean, first of all, would you want to see this kind of technology in London? And is it invading our privacy? Is there sort of like a line where there is technology and where there is privacy? And do you have any comments on that here?
Yeah, what I'll say is the Europeans are ahead of the Americans in that space. GDPR is pretty good about addressing personal information, including your like and image and security cameras. So there's already some rules put in place around that. The challenge is it's that balance again of convenience and opportunity versus privacy. It's great when we get our phone back, but we've given away all of our data. If you go to the airport in the United States and you travel internationally now, you don't travel internationally off of a boarding pass. You walk up, you get a camera, and it knows you off of your passport. You can opt out. But yes, there is absolutely a balance to it. Technology is really, it's a convenience item. So I don't know that I have a great answer other than I feel like we probably need to have better considerations for that as we build it in. And part of that is, like we talked about, what are we expecting of the vendors that are building these systems? Did we put a requirement into their expectations? Because otherwise, we don't know.
Thank you once again for being such an informed and super engaged audience. And we very much appreciate your support and your contribution to the conversation. I'd just like to invite everybody to give David another round of applause.